Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to troubleshoot one network issue and see the problem. What is problem? So guys, an engineer has configured this topology, this network, and after that the customer is complaining that remote users are not able to communicate with each other. So this topology is pre-configured and engineer has already configured this topology, but remote users are not able to communicate with each other. And as a network engineer, you need to troubleshoot it. So guys, first of all, we will verify the issue that really remote users are not able to communicate with each other. If yes, remote users are not able to communicate with each other, then we will troubleshoot it, we will fix it, and then we will save the configuration. Now without wasting our time, let's begin. So see, first of all, let me make you familiar with this topology. After that, we'll start troubleshooting. So guys, in my topology I have three routers: router 1, router 2, and router 3. All these three routers are connected through internet. You can say these are branch offices. Like you can see, router 1 is my hub router. So let's say router 1 is hub router or headquarter router in India, right? Router 2 is a spoke 1 in, let's say, US, and router 3 is the spoke 2, let's say, in the Australia, right? So I have three branch offices, and all branch offices are connected together with the help of internet. And guys, the subnet which I am using between these routers is 192.168.10.0/24. Then I have some subnets on router number 1, I have some subnets on router number 2, and some subnets on router number 3. So here issue is all remote users are able to communicate with headquarter users, right? Means headquarter users are able to communicate with spoke 1 users as well as with spoke 2 users. But the issue is these two branch offices are not able to communicate with each other. Spoke 1 and spoke 2 are not able to communicate with each other, right? Hope now this topology is clear, and now I am going to start the troubleshooting. First of all, let me verify the connectivity. What I can do, simply I can ping any remote user from hub router. So now you can see I have access of all these three router 1, 2, and 3. To verify the IP, simply you can run command show IP interface brief exclude unassigned. So see the IP configuration, guys. On F0/0 my IP address is 192.168.10.1, and on loopback interfaces, on loopback 1 10.1, on loopback 2 10.1.2.1, on loopback 3 10.1.3.1. In the same way, on router number 2 also you can verify the IP. So see IP on fast ethernet 0/0 is 192.168.10.2, and then I have some loopbacks like 10.1.1.20.1.1.1, 20.1.2.1, 20.1.3.1, right? And on router number 3, so IP interface brief exclude unassigned. On router number 3 also, guys, on F0/0 IP address is 192.168.10.3, and then I have some loopbacks IP address. So if all remote users or spoke users are able to communicate with hub users or headquarter users, that means, guys, these all routers are able to communicate with each other. Routers are able to communicate with each other. So how we can verify it? Simply I can ping router 2 from router 1, or I can ping router 3 from router 1. So let me do one thing, ping 192.168.10.2, which is the IP address of router 2. Let me ping this IP address, and you can see ping is working. In the same way, I can ping 10.3 to router number 3. See, I'm able to ping router 3 also. Now from the router number 2, I'm going to ping router 3. Let me verify the connectivity. 192.168.30.1. Sorry, 192.168.10.3. So you can see I'm able to ping router 3 from router number 2. Now I am going to verify end-to-end connectivity. So to verify end-to-end connectivity, let me do one thing. Let me ping 20.1.1.1 from 10.1.1.1. So you can see 10.1.1.1 is one user in the headquarter, and 20.1.1.1 is one user in spoke 1 in the branch 1, right? And these two users are able to communicate with each other. Now I am going to ping any user in the spoke 2 in the branch 2. Let me ping 30.1.1.1 and say source again 20.10.1.1.1, and see, guys, this ping is also working. Means user from hub router, means headquarter, is able to communicate with users in branch 2. All are able to communicate. Now I am going to finally verify the connectivity between branch offices. So let me take you to router number 2, and from router number 2 I am going to ping, let's say 30.1.1.1 and say source 20.1.1.1. 20.1.1.1 is one user in spoke 1 and 30.1.1.1 is one user in remote branch in spoke 2. And see guys, this ping is not working, right? Yes. So really remote users are not able to communicate with each other. Now what can be the issue? See, there are many factors, right? Many things you need to check here to troubleshoot it. But guys, we'll start troubleshooting from the zero. So first of all, you will check the route is available in the routing table or not, right? This, why these routers are not able to communicate, is there any filtering configured on the interface? So let me start the troubleshooting. Before that, I can do one thing. I can ping to any other user to check that only this specific user is not reachable, or complete user or complete subnets are not reachable. So ping 30.1. let's say 2.1 and source 20.1.2.1. so see, this user, this ping is also not working, correct? And from the router number 3 also you can ping to 20.1.1.1 and source 30.1.1.1. see, ping is not working. That means it is clear that both branch offices are not able to communicate with each other, but all branch offices users are able to communicate with headquarter users, right? So issue is clear. And from the router number 3, if you will ping to headquarter like 10.1.1.1 and source 30.1.1.1, see, this ping is working, right? Means remote users are able to ping headquarter users. Now guys, let's start troubleshooting. So to troubleshoot, if you are not able to ping user in 30 network, right, 30.1.1.0 or 30.1.2.0 or 30.1.3.0. So first of all, you will check routing table, because route should be available in the routing table, right? Then only router can forward traffic. So let me run command so IP route, and if I am pinging to 30.1.1.0 255.255.255.0, right? So I am on router number 1. I need to run this command on router number 2 actually. So IP route 30.1.1.0 and 255.255.255.0, and see, this network is not in the table. So actually router 2 don't have route for 30 network, right? Is as well as for 30.1.2.0 second subnet in the remote, in the branch office 2. See, we don't have route for 30.1.2.1 and 30.1.3.1. see, I don't have route, right? So these networks are not available in the routing table of router 2. This is why end users are not able to ping 30 users, right? In the same way, you can verify the routing table of R3. And before that, like if you will check routing table for, let's say 10.1.1.3, 10.1.3.0, right, which is running on headquarter. So see, for this network, route is available in the table. Like this network is reachable via, guys, 192.168.10.1, which is the IP address of router 1, right? So actually router 1 is advertising this network, right? Now on router number 3, so IP route, and here I am going to verify 20 network 20.1.1.0. see, so IP route IP route 20.1.1.0 255.255.255.0. so see, network not in the table. So this network is not in the table. Again 20.1.2.0, 2.0 is also not there, and 3.0 is also not there, right? 3.0 is also not there. Now you can check complete routing table like on router number 1, so IP route. So see the complete routing table of router 1, guys. In the routing table of router 1, we have all connected network, means all 10 networks, as well as all 20 networks, means branch office 2 network, and all 30 network, right, means 20 networks are running at branch office 1 and 30 networks are running at branch office 2. So hub router 1 have all route in the routing table, but router 2, so IP route, so router 2 have, see, all their directly connected network, all 20 networks, 20 subnet, as well as all 10 subnets, means all subnet of headquarter. But guys, router 2 don't have route for branch office 2 subnets, like 30 networks are not available. In the same way, you can verify the routing table of R3. So IP route. So here also you can see we have all directly connected networks, 30 networks, as well as 10 networks which are running on headquarter, but I don't have any 20 networks, correct? So now we have verified that router don't have route in their routing table, right? So this is the reason why these users are not able to communicate. Now we need to troubleshoot why these router don't have route, right? Where is the issue? So guys, see, to exchange route between routers, we have two options. Either I can configure a static routing, or I can configure what? Dynamic routing. So you can check the routing protocol, which routing protocol is running here. So IP route. If I'm running this command, you can see R1 is learning remote networks with EAGRP, right? That means my routing protocol is EAGRP. My routing protocol is EAGRP in this case. So what you can do, you can check the detailed configuration of EIGRP, right? Like, is there any filtering applied in EIGRP on router number 2 or router number 3? So let me take you to router number 2 and say so IP protocol. Here this command will give me many information, right, about the routing protocol. As routes are not available in the routing table, I am going to check protocol configuration, right? So IP protocol. See guys, outgoing update filter list for all interfaces is not set. So there is no any filtering for outgoing traffic, right, for outgoing update. And incoming update filter list for all interfaces is not set, right? So there is no filtering for incoming update as well as for outgoing update on router number 2. Then default network, okay, key values, we don't need to check key values because we have neighborship. So IP EIGRP neighbor, we have neighborship, neighbor is 10.2. So as this is hub and spoke topology, you can see we don't have EIGRP neighborship between router 2 and router 3, right? Router 2 have neighborship with router 1. Here we have one EIGRP neighborship, and here we have one EIGRP neighborship. Here we don't have any neighborship like between router 2 and router 3. Done. So neighbor is fine. Router 2 have neighborship with router number 1. Again, let me take you to the output of so IP protocol command. So IP protocol. So we don't need to check key values or timers. Router ID, AD values. Okay. Automatic summarization is disabled. Maximum path 4. Okay. Routing gateway. Fine, everything look like fine here on router number 2, right? In the same way, I can check the routing protocol on router number 3. So IP protocol, and on router number 3 also you can see there is no any filtering for outgoing update as well as for incoming update. Fine. So guys, automatic summarization, okay, rest configuration looks like fine here, right? Then why router 2 is not receiving network information, remote branch office network information? Now I am going to check the EIGRP configuration on router number 1, because it is possible that router 1 is filtering the update, right? So let me say so IP protocol, or before that so IP EIGRP neighbor. So you can see router 2 have two neighbor, 192.168.10.3 means router 3 is spoke 2, and 192.168.10.2 means router 2 is spoke 1. Then so IP protocol. So protocol, there is no any filtering, right, for outgoing traffic as well as for incoming traffic. Done guys. So rest configuration looks same like router number 2 and router number 3. Now what we can do, as you know, EIGRP maintain 3 tables: neighbor table, topology table, and routing table. Let me check remote routers have the network information in topology table or not. It is clear that networks are not available in the routing table. Now let me verify the topology table. So IP EIGRP topology. So guys, in the topology table of router 2, you can see we have 192 network, 20 network, as well as all 10 networks, right? So here we don't have 30 network in the topology table as well. On router number 3 also, so IP EIGRP topology, right? So you can see we don't have 20 networks here in the topology table. Now we need to troubleshoot the issue. What is the issue, right? Till now guys, all configuration looks fine, right? Everything is working fine, but why router branch offices users don't have remote branch office routes, right? Like router 2 don't have 30 network and router 3 don't have 20 network. So try to understand the packet flow now. When I will configure EIGRP here in this scenario, what will happen? So guys, when I will enable EIGRP on these all routers are going to first generate hello message, then it will form neighborship. After that, router 2 is going to advertise these all network to router number 1 to their neighbor, and router 1 is going to advertise all network information to their other neighbor, right, to router number 3. So this is how router 3 will run all 20 networks, and router 3 will advertise these all network to router number 1, and then router 1 will advertise those network to their other neighbor to means router number 2. So this is how router 2 will get 30 network information, right? But issue is both neighbor are connected with same, both neighbor are connected on same interface on F0/0. You can see on this interface both neighbor are connected. So on router number 1, so IP EIGRP neighbor. So you can see both neighbors are on the same interface on fast Ethernet 0/0. So if both neighbor are on the same interface guys, in that scenario a split horizon feature should be disabled, because what a split horizon feature tells, it tells do not send the update message from the receive interface, same update message from the received interface. So that means when router 2 will receive these network information from router number 1 on F0/0, router 1 is not going to forward it from their same interface, right, because of split horizon. So now let me check split horizon is enabled or disabled. So when you will check the flow of EIGRP, like how EIGRP routers are going to exchange update, in that time you will get to know about the split horizon, right? So let me do one thing on router number 1, or see first on router number 2. So IP interface F0/0. On this interface have joined this multicast group which is reserved for EIGRP, and proxy are fine. See, a split horizon is enabled, so that is fine. On router number 2 a split horizon should be enabled, but on router number 2 a split horizon should be disabled, right? Sorry, on router number 2 a split horizon should be enabled, but on router number 1 a split horizon should be disabled. So now let me take you to router number 1, and here I need to check a split horizon. So IP interface F0/0, or say include split. Okay, so see, EIGRP is enabled on this interface, fine, and oh, a split horizon is enabled over here. So if a split horizon is enabled, then router 1 will not advertise 20 network to router number 3 and 30 network to router number 1, right? Because it will not share same update message from the received interface. So what we need to do actually here, we need to disable a split horizon. Once I will disable a split horizon, router 1 can advertise 20 network to router number 3 and 30 network to router number 2. So let me do one thing, let me take you to router number 1, and so IP interface F0/0. Here also you can see a split horizon is enabled. So if a split horizon is already enabled, then there will be some problem. Like in that scenario, again, two branch offices cannot communicate with each other. If there is any other issue, then we will troubleshoot it. But first of all, we need to disable a split horizon here. Interface F0/0 and say no IP speed horizon. See, by default this command is running split IP IP speed horizon for EIGRP ES number 10. By default this command is running. This command is inbuilt in the protocol, right? So when you are enabling EIGRP on the interface, automatically EIGRP will enable speed horizon feature there. But if you want to remove this command, simply you can say no to this. By default it is enabled, no to this. And now you can see again router have resynchronized the neighborship. Router have resynchronized the neighborship, and now if you will check the input, see speed horizon is enabled. This is guys incorrect output here, right? But now speed horizon is disabled for EIGRP 100. Actually it's showing a speed horizon for RIP protocol, but for EIGRP you have disabled the speed horizon. If there is any other command, let me check. So IP EIGRP interface f0/0 detail or detail f0/0 detail f0/0. So here you can see speed horizon is disabled. So I have disabled speed horizon for EIGRP now, right? By default this command is running interface f0/0 IP split horizon for EIGRP S number 10. So if this command is running, then you can verify speed horizon is enabled. Speed horizon is enabled. So we need to disable speed horizon here on router number 1. So say f0/0 and no IP speed horizon for EIGRP S number 100. And so IP interface f0/0. So this speed horizon is talking about a RIP protocol, guys. So in the RIP routing protocol, speed horizon is enabled, but in EIGRP now speed horizon is disabled. In the EIGRP speed horizon is disabled, you can see here. So if speed horizon is disabled, what I am expecting now, branch offices should have route for remote branch offices. So let me say so IP route EIGRP, and now guys you can see router 2 have all 30 network informations. In the same way you can check topology table also. So IP EIGRP topology and state for all 30 networks is passive, so that's why router have installed it in their routing table. So now we have remote branch subnets on router number 3 also. So IP route EIGRP, and you can see we have all remote routes, right? All remote subnets in the routing table. So now if ping is not working, again you are going to run same command. So IP route and 30.1.1.0 255.255.255.0. So this time you can see route is available, right? This network is known via EIGRP S number 10 and distance for this network is 90. So whenever we will troubleshoot routing issue, we are going to check routing table like this only, right? This command will give detailed information of the route, like what is the distance, what is the metric, this route is known by which protocol. So this network is known by EIGRP 10, distance is 90, metric is this one, right? And which type of network it is internal network. Last update from this neighbor 192.168.10.1 on fast ethernet 0/0, right? Uptime is 1 minute 25 second ago. Done. And this next hop is reachable. That means now I can forward traffic to ping 30.1.1.1 and say source 20.1.1.1. So now you can see ping is working, right? Now these two branch offices can communicate with each other. Ping 30.1.2.1 and source 20.1.2.1. See, 20 subnets and 30 subnets are also able to communicate, and ping 30.1.3.1 and source 20.1.3.1. See, ping is working, right? But as this is hub and spoke topology, all communication will happen, all data will travel via hub router. So if you will trace route 30.1.1.1 and source 20.1.1.1, say numeric. See, my traffic is going to router 1 first, 10.1, then router 1 is forwarding it to router 3. But guys, in the hub and spoke topology also, two branch offices can communicate directly with each other, right? Like these users can communicate with each other via internet. So again, in that scenario, you need to remove one command from the router 1. See, right now what is happening on router number 2? So IP route EIGRP. So we have all 30 networks, remote site networks, and these all networks are reachable via 192.168.10.1. Actually, what is happening? See, when router 1 will advertise these all 20 networks to router number 1, it will install these all network in their topology table, then it will install it in routing table, and router 1 is going to also advertise these all network to their other neighbor, means to router number 3. When router 1 will advertise it to router number 3, source IP address is going to be what? Their exit interface IP address, destination IP address, multicast, right? And that exit interface IP address will become next hop IP address on router number 3. Same thing is happening on router number 2. When router 3 will advertise this network to router number 1, router 1 will update their database and then it will advertise to their other neighbor, means router number 2, and it will update what? Next hop IP address. So as hub router is updating next hop IP address, these networks are reachable via hub router, right? Because next hop IP address is hub. So to avoid it, if you want that users should be able to communicate with each other directly, what you can do on router 1, I can remove this command, like on interface f0/0. See, by default one command is running, that is IP next hop self for EIGRPS number 10. And if you will remove this command, then router 1 is not going to update next hop IP address. And if router will not update next hop IP address, guys, then see router 2 routing table now. So IP route EIGRP. Now you can see the next hop 192.168.10.3, right? If you will open this network in detail, so IP route and 30.1.1.1 0 255.255.0, you can see again this network is known via EIGRP 10, distance is this 90, metric is this one, route type is internal, right? Last update and next hop IP address 192.168.10.3 on fast ethernet 0/0 192.168.10.3, but not receive the update message from 192.168.10.3. This is the next hop IP address, but it have received from which neighbor, guys? From 192.168.10.1, from this neighbor, right? So now if you will trace again 30.1.1.1 and source 10.1.1.1, say numeric, sorry, not 10, 20.1.1.1. Now you can see traffic is going directly to other remote branch, right? So now everything is fine. My remote users are able to communicate with each other, and hub branch offices user, hub means headquarter users are also able to communicate with all branch offices, right? Now you can save the configuration. This is how to troubleshoot a split horizon issues, guys, right? If you are a network engineer company where two branch offices are not able to communicate with each other and you are running EIGRP, and like you can say, whenever we have two EIGRP neighbor on a single interface, in that scenario we should always check speech horizon. Like in this scenario, you can see router 1 fast ethernet 0/ on this interface we have two neighbor. So in this scenario we should check speech horizon first, right? So while configuring this network, the engineer has forget to disable speech horizon here. This is why there was issue. Now we have fixed the issue, and that's all for today, guys. If you have learned something from this video, if this video was helpful for you, and if you want more videos like this, then please hit on like button, right? And if you have any question, query, then please let me know in the comment section. If you are looking for any paid live course, then please visit pmnetworking.in, www.pmnetworking.in, on my website, where you can check the upcoming batches. Soon we are starting CCNA batch. After that we'll be launch CCNA plus CCNP combo batch. If you are looking for any course like CCNA, CCNP, SD-WAN, MPLS, service provider, data center, SD-WAN, right, you can check the course. All courses are available on the website, and according to your comfort you can enroll in the upcoming batch. That's all for today. Thanks for watching. Bye bye. We'll meet soon in next video. Till then, stay safe. Bye bye, guys.